Morning, guys. I'm here sitting in my house and I'm drinking myself some Coca-Cola. Nothing better to kick off your morning than drinking a highly sugary drink. Yeah, it's a lot of sugar. You might be asking yourself, how do I know that Coke has a high percentage of sugar? Well, it's not actually because I'm super smart and know everything. It's actually because I know how to calculate percent. I remember from, I don't know if this is algebra, but at some point in my schooling, I learned how to calculate percentage. It's a really simple formula. I drew it out here for you. It's essentially part divided by whole times 100. It's 100. Well, in the problem I just mentioned, in the amount of sugar in Coke, sugar is my part. Okay, that's the small thing. The percentage that I'm looking at is the part. The whole is what I'm looking at this percentage compared to. I'm looking at the percentage of sugar compared to the total amount of Coca-Cola in this can. So Coke is going to be my whole. Usually in percentage, in our class, we're going to be using grams as our percentage. So I just looked on the nutrition facts label on this Coca-Cola. As you can see in the Coca-Cola can, there's 45 grams of sugar in this Coke. So that's going to be my part, and I labeled it right here, 45 grams. I measured the amount of Coke in a Coke can, and the total amount of Coke weighed 394 grams. And so now that I have my part and I have my whole, I divide them. But that doesn't give me a percentage, that gives me a decimal number. So to find a percentage, all you do is you multiply times 100, and then you get your percentage. So the percentage of sugar in Coke is 11.4. 11.4% of this liquid is sugar, which is a very high percentage when you're talking about a beverage. So how do we use that in chemistry? Well, in chemistry, we don't look at Coke. We don't study Coke. We study molecules, okay? So this is really, this formula down here is really the exact same thing that I've just been teaching you, except I used words molar mass. This is your part. So if you're looking at the molar mass of an element, that element will be your part. The total compound is your whole. So in chemistry, we're going to be using, that's a horrible whole, sorry. Okay, HWOLE, here we go. That's our whole. And you multiply it times 100, and that's how we find percent. So let's do some sample problems together. Find the percentage of copper and sulfur in the compound copper 1 sulfide. Well, the first thing I have to do is write out the formula. I need to know what copper 1 sulfide is, and it's not CuS. Why is it not CuS? Well, because it's an ionic compound, and I have to even out charges. Copper's charge is given to me right here. Okay, it's the Roman numeral, so copper's charge is +1. If copper has a +1 charge, and sulfur, when I look on the periodic table, it's in group 16, so it has a -2 charge. I know I need 2 coppers to even that out. So my formula is Cu2S. So if I'm trying to find the percentage of copper and sulfur, I need to know my part and my whole. Essentially, you're doing 2 problems. We're first going to find the percentage of copper, then we're going to find the percentage of sulfur. To find the percentage of copper, I need the part, which is grams of copper, and then I need the whole, which is grams of my whole compound. Okay, so how many grams of copper do I have? Well, remember that you don't just have 1 atom of copper, you have 2 atoms of copper, so you can't just write down the molar mass of copper. The molar mass of copper is 63.55. I cannot put 63.55 in the top blank because I don't just have 1 copper, I have 2 coppers. So since I'm trying to find Cu2, I have to multiply this by 2, which gives me 127.1. So that's my part. 127.1 grams of copper is in 1 mole of Cu2S. So now I have to find the molar mass of the whole compound and put that here. So I already know Cu2 weighs this much. So how much does sulfur weigh? Well, sulfur, we only have 1 sulfur, so I just have to look on the periodic table, and sulfur's molar mass is 32.07 grams per mole. So all I have to do is add these 2 together to find the molar mass of my whole compound. When I add them together, I see that it's 159.17 grams for 1 mole of Cu2S. So since copper weighs 127.1 and the whole compound weighs 159.17, I can see that copper should weigh should be a significant percentage of the weight of this compound. So now I'm just going to divide these two numbers, multiply by 100, and my percentage of copper is 79.9% of this compound is made of copper. Now let's do sulfur. To find the percentage of sulfur, I need to find the grams of sulfur, that's my part, and the grams of Cu2S. Well, I've already calculated the grams of Cu2S. Remember, it's right here. So I'm just going to use that same number down here. My whole does not change. The only thing that's changing is my part. Okay, I'm now putting grams of sulfur. We also already found that right up here. The grams of sulfur is just the molar mass from the periodic table. So I write 32.07 grams of sulfur. When I divide them and multiply by 100, I get 20.1% of the compounds made of sulfur. Now, a way to check yourself before you wreck yourself is make sure the results add up to 100%. Does 20.1 and 79.9 add up to 100%? Yes, then I'm good. As long as all of your parts will add up to the whole, then you know you did your math right. Okay, let's do a couple more examples. Okay, in this question it's asking me which element has a greater composition in the compound Li2O. So I have to find the percent of lithium and the percent of oxygen. Before I do that, I need to find the parts and I need to find the wholes. So the whole, I need to find the part, so how much does Li2 weigh? I need to find out how much O weighs, and then I need to find out how much Li2O weighs. Okay, so this is my whole, and each of these are my separate parts. Now lithium, remember, you have to multiply whatever lithium's molar mass is by 2 in order to get the molar mass. So lithium on the periodic table has a molar mass of 6.94. So when I multiply that by 2, I know that the molar mass of the part of lithium weighs 13.88 grams. Okay. Oxygen, there's only one oxygen in this compound, so I just have to find the molar mass of oxygen, which is 15.99 grams. And then how much does my whole compound weigh? Well, I just have to add these two together. I add 13.88 to 15.99, and I get 29.87 grams of my whole compound. Now I'm going to use these numbers to find my percentage. Remember, to find percent of lithium, you need grams of lithium over grams of your whole compound. Grams of lithium is right here, 13.88 grams. My whole compound is right here. It's 29.87 grams of Li2O. Remember, don't forget, you always have to multiply by 100. So I divide part divided by whole times 100. And for lithium, lithium makes up 46.4% of the compound, a little bit less than half. Okay, so now to do oxygen, I do the same thing. I'm going to do grams of oxygen divided by grams of my whole compound. So how much does oxygen weigh? Well, it's right here. It's 15.99 grams of oxygen divided by my whole compound, which is 29.87 grams of lithium oxide. Multiply that by 100 and I'll get the percentage of oxygen, which is 53.5%. Sorry, that's 6%. Again, make sure that these two numbers here will add up to 100% to make sure that both your parts add up to 100. Okay, I want you to try and do the last problem on your own, and we'll go over this problem in class together. And that's it for today. You'll have a wonderful day, and remember that every time you drink a Coke, you're drinking 11.4% of what you're drinking is made of sugar. Crazy.